Our next presenter is Nate Watson of xForm Technologies. Nate, you may begin.
So hello, my name is Nate Watson, and I want to introduce you to xForm Technologies. You're probably familiar with plastic desktop 3D printers, but xForm Technologies steps this concept up with concrete 3D printing. Similar to plastic printers, concrete printing uses concrete extruded through a nozzle to form a 3D shape layer by layer without the use of labor-intensive formwork. Using this technology, we intend on being part of the solution of a problem spread across the entire construction industry. Labor issues and shortages within construction, driven by the lack of productivity, has placed it in a position ripe for innovation. As time has gone by, the public perception of construction is that it is dangerous, difficult, and dirty. As industries such as agriculture and manufacturing have invested in technology and innovation, the construction industry has been relatively stagnant. We have found by looking at precast concrete products and visiting facilities, and by talking to precast concrete manufacturers, that they would be a great first customer segment to pursue. Precast concrete manufacturers have facility conditions similar to the lab and produce products at the size that our system has produced. The precast industry is also quite large, with 1,827 US companies and a market size of over $130 billion. What we have heard from precast companies is along the same lines of what we see with the stagnant construction industry as a whole. Labor is a limiting factor and prevents them from completing all their potential bids. They lose money on custom designs in order to maintain high value customers. And they experience high job turnover costs. And if they want to make a new product, the formwork for it can be very expensive with long lead times. Our business seeks to alleviate those pain points using our technology by increasing per worker productivity, removing the need for custom formwork, changing the job perception through automation, and allowing businesses to diversify products without the cost of new forms. We plan on doing this while also creating a new business possibilities for our customers as a side effect, because as we know, to enter any market, especially a conservative one, being able to solve their current problems costing them money now is going to get us in the door. And being able to improve their products and help them attract a broader group of happy customers will get us in many more doors. This differs from our concrete printing competitors who want to be their own construction companies and compete with current construction practices as a whole. Our strategy is to work with construction companies by addressing their pain points and grow our market segment with the technology rather than trying to compete with the entire industry as a whole. After developing our award-winning system at Penn State, which won nearly $500,000 in competition winnings, and our award-winning participation in the Tech Accelerator and the completion of the Summer Founders Program, my co-founders and I are ready to use our expertise in additive manufacturing and design, mechanical engineering, systems engineering, architectural engineering, and architecture to make xForm's technology a success. xForm Technology is now ready to continue to develop with close contact with excited potential customers, begin consulting with interested universities, pursue SBIR grant funding, and work alongside Penn State for testing to make sure our product is as good as we think it can be. Thank you so much for listening, and I look forward to answering any of your questions.
Thank you, Nate. That was a nice presentation. All right, we will now start our Q&A, beginning with Alana.
Thank you, Nate. That was great. I have a question. You talk about Precast as the main competitor, and I imagine that it's much cheaper and better suited, let's say, to making hundreds or thousands of the same form again and again, and that you're better for individual to custom. Is that correct?
So yeah, so the precast industry suffers from limited labor, which when we talk to them, they're addressing their current pain points now, which is the fact that they don't have enough labor, and the labor is getting because of shortages and that limited supply, the price is also increasing, and the turnover cost from hiring and losing people is also a driving factor. And so what we claim is we can come in and help increase that per worker productivity by eliminating the need for the multiple workers needed to produce particular products, and then as a side effect, basically our technology will also provide zero cost extra for custom designs, as well as allowing businesses to diversify their products.
Okay, so I get why on a custom design that would make sense, but I'm wondering what % of the market is actually those custom designs, and I guess if you could explain to me, why would this be more cost effective than precast in a situation where you're making the same thing again and again hundreds of times?
Yeah, that's a great question, because so you would think that precast is the cheapest way of producing the same product over and over again. And that makes sense. But what we hear is that it takes, because of the, especially the reinforcing process, the molding and then demolding process, it ends up taking many workers to produce one part, where using our technology, it may take one worker to operate the machine, and it can continue to produce concrete products with a lot shorter turnover because of the curing process, but also just fewer workers as a whole, just because it doesn't require, sometimes it might require 4 workers, hours of work just to do one form, even though that they own the formwork. Yeah.
And so once the 4 workers do it, they can't make 1,000 pieces each time it takes 4 workers?
Yes, it does.
Oh, wow. Okay.
Yeah, it can cost thousands of dollars in labor costs to create some of these forms.
Okay, thanks.
Nate, very interesting. Have you gone as far as to sort of sit down with one of these customers or prospective customers and figure out, how much you can reduce their cost of goods on a routine piece? Can you cut it by 20%, 50%, 70%? What is it?
So we have talked with multiple precast manufacturers and kind of looked at their product portfolio and to see what the technology can do now versus what requires development. But in terms of the actual cost cutting per product, I think that's harder to gauge at the moment. Although part of our targeting is to create like the productivity of our system equivalent to like man hours or a person hired, for example, and create our leasing price structure cheaper than what our system can produce, basically.
Your system is to lease the equipment?
So it would be to sell the equipment, and there are our hypothetical sale we're thinking might go through a leasing company or a bank or some sort of form, but we would probably just sell the company, just sell the product. Sorry.
Okay, thank you.
I know I'm supposed to ask a question, but I just want to follow up on that. Robotics as a service is also really hot right now. So it's a form of leasing, but you can subsidize the cost of the equipment, and they would pay per, I don't know, square foot or whatever that they would be manufacturing. But that leads me into my question. So I'm thinking about scale. So size scale and time scale. So in terms of size, these concrete can be really large, especially if you're using them for building. So how large is your system capable of handling right now? What dimensions, and what percentage of the market does that cover? Yeah,
so that's another point about precast concrete is often the size of the products that they're producing. It needs to fit on a flatbed truck, and so that's part of the reason why I think a lot of the precast products are actually can be smaller. I mean, obviously it can be much larger with wide loads and things like that. But in terms of size, you can imagine a flatbed truck and what can fit on there. I know from the last slide, you could see part of what we had printed before in competition as being roughly that size of maybe a half of a flatbed. But we're excited to continue development and scale that up with likely moving the robot and things like that. But it ends up being a very large market size. Yeah.
Awesome. One last one on the time scale. You talked about man hours, but also the precast takes a couple of people. But how long, I guess, end to end linearly does your process take versus the conventional method?
Yeah, so the printer needs to be obviously operating the whole time versus letting pouring and letting it sit. But if you think about it as like because of the manufacturing type with 3D printing, it requires the material sets, and so basically right when the print is finished, within probably around of 30 minutes, 0 to 30 minutes, the concrete part can be moved off of the manufacturing floor, which opens up more space and can help with the turnover for the machine to print another product versus having a bunch of forms, filling those forms with concrete, and then having to wait for that concrete to cure enough to demold it before you can reuse that form.
Thanks.
Thank you, judges, for your questions. Those were great. And thank you, Nate, for your presentation. A very interesting market.
Yeah, thank you.